What I want to figure out in this video is the area under the curve y equals 1 over x squared with x equals 1 as our lower boundary and have no upper boundary. Just keep on going forever and forever, as it really is essentially as x approaches infinity. So I want to figure out what this entire area is. And one way that we can denote that is with an improper definite integral, or an improper integral. And we would denote it as 1 is our lower boundary, but we're just going to keep on going forever as our upper boundary. So our upper boundary is infinity, and we're taking the integral of 1 over x squared dx. And so let me be very clear. This right over here is an improper integral. Now, how do we actually deal with this? Well, by definition, this is the same thing as the limit as n approaches infinity of the integral from 1 to n of 1 over x squared dx. And this is nice because we know how to evaluate this. This is just a definite integral where the upper boundary is n, and then we know how to take limits. We can figure out what the limit is as n approaches infinity. So let's figure out if we can actually evaluate this thing. So the second fundamental theorem of calculus, or the second part of the fundamental theorem of calculus, tells us that this piece right over here, actually, so let me write the limit part. So this part, I'll just rewrite the limit as n approaches infinity and we're going to use the second fundamental theorem of calculus. We're going to evaluate the antiderivative of 1 over x squared, or x to the negative 2. So the antiderivative of x to the negative 2 is negative x to the negative 1. So negative x to the negative 1, or negative 1 over x. So negative 1 over x is the antiderivative, and we're going to evaluate it at n and evaluate it at 1. So this is going to be equal to the limit as n approaches infinity of, let's see, if we evaluate this thing at n, we get negative 1 over n. So we get negative 1 over n. And from that, we're going to subtract this thing evaluated at 1. So it's negative 1 over 1, or it's negative 1. So this right over here is negative 1. And so we're going to find the limit as n approaches infinity of this business. This stuff right here is just this stuff right here. I haven't found the limit yet. So this is going to be equal to the limit as n approaches infinity of, let's see, this is positive 1, and we could even write that minus 1 over n, of 1 minus 1 over n. And lucky for us, this limit actually exists. Limit as n approaches infinity, this term right over here is going to get closer and closer and closer to 0. 1 over infinity you can essentially view as 0. So this right over here is going to be equal to 1, which is pretty neat. We have this area that has no right boundary. It just keeps on going forever, but we still have a finite area, and the area is actually exactly equal to 1. So in this case, we had an improper integral, and because we were actually able to evaluate it and come up with a number that this limit actually existed, we say that this improper integral right over here is convergent. If for whatever reason this was unbounded, we couldn't come up with some type of a finite number here, if the area was infinite, we would say that it is divergent. So right over here we figured out a kind of neat thing. This area is exactly 1.